So yesterday we have seen what is the specific conductance and equivalent conductance. Equivalent conductance is denoted by lambda v, and specific conductance is denoted by kV. Up to this we have seen. Okay. Now the equivalent conductance term was used previously. Now it is related to molar conductance. Now what is molar conductance? Say the conductance of a solution containing 1 gram mole of electrolyte. Equivalent conductance was the conductance of solution containing 1 gram equivalent of electrolyte, that is the equivalent conductance, and the molar conductance is the conductance of solution containing 1 gram mole. Okay. Now the equivalent conductance is, for example, suppose the electrolyte is the bivalent. For example, say barium sulfate. Sorry, barium sulfate is sparingly soluble. Barium chloride. Then equivalent conductance is mentioned as half BaCl2. Means this barium has +2 charge. So its equivalent weight is molecular weight divided by 2. So likewise, we have to take the molar conductance and equivalent conductance. Now, the conductance, either it may be observed conductance, or it may be specific conductance, or it may be equivalent conductance. That conductance depends upon the mobility of ions. Because in an electrolytic solution, when we take solution of electrolyte, when we take such solution of electrolyte in a container and we place the electrodes, then the ions moves from side of this to the towards the electrodes, oppositely charged electrodes. Okay. If the movement of ions is fast, means the mobility of ions is fast, then the conductance will be more. So the conductance depends upon the mobility of ions. Conductance of solution depends upon the mobility of ions. Just like metallic conductors, the conductance depends upon the mobility of electrons. So in solution conductance, the the conductance of solution depends upon the mobility of ions. And this mobility of ions is governed by 4 factors. This mobility of ions is governed by 4 factors. First is the electrical force. First is the electrical force. Second, the frictional force. Third, electrophoretic effect. and fourth is the relaxation effect. So the mobility of ions is governed or affected by these four factors. So indirectly, the conductance of solution is affected by these four factors. Okay. Now, in the solution of strong electrolyte, in the solution of strong electrolyte or the solution at higher concentration, solutions at higher concentration, these two factors are negligible. These two factors are negligible. What are these factors that we will see later on? But this, in the solution of concentrated solution of electrolytes, only these two factors are there: electrical force and frictional force. Sorry. What is this electrical force? The positively charged electrode attracts negatively charged ions towards itself. The negatively charged electrode attracts positively charged ions towards itself by the electrical force. If greater the electrical force, then the greater will be the mobility. Suppose this is the positive pole. If it has higher magnitude, then it can attract strongly this negative particle. Then this negative particle moves fast towards this positive particle because of stronger force of attraction. If it is weakly attracted, then it moves slowly. So the conductance will be less or more depending upon this electrical force. Okay. Now another one is the frictional force. Another one is the frictional force. Now suppose we have taken solution of NaCl. There are positive ions and Cl negative ions in the solution. Now suppose if that Cl minus ion has to go towards the positive electron. Cl minus ion has to go towards the positive electrode. Cl, suppose this is Na positive, Cl negative, is moving towards the positive electrode. Now during this motion, just now we have seen the electrical force, this positive electrode attracts this negative chloride ions towards itself. Now there are Na plus ions. This Na plus ion attracts chloride ions towards itself. There are, suppose there are, this is Na plus ion is at this side of Cl. They like this. So that has to friction, that is friction force. That is the friction force. If that friction force is more, then the mobility of ions will be less. Ions will be less mobile if they have more frictional force. Okay. It is just like frictional force between two solids. When we rub such two solids on each other, then there is the frictional force between these two. Same just like there is a frictional force in the solution. Okay. Now the electrophoretic effect is the effect when this sodium is there. Sodium plus ion is there. Sodium plus. Now the water molecules surround this sodium plus ions. Water molecules are like this. Oxygen bears partial negative charge. Hydrogen bears partial positive charge. So this Na plus is surrounded by such water molecules, or we may say, instead of saying water molecules, solvent molecules, like this. Now this what happens, this can neutralizes, this can minimizes the positive charge on the Na plus ions. Same is with chlorides. Same is with chlorides. These chloride ions were surrounded by water molecules, and because of this, they minimize. Suppose this is Cl minus, Del plus, Del plus. This is surrounded by the water molecules like this. So because of this, the negative charge or positive charge is minimized. And because of this minimization of charge, less force of attraction between the positive oppositely charged electrodes and these ions. This is one. And another one is these are becomes bulky, their size becomes greater one, larger one. And the larger sized ions has less mobility. Larger size ions have less mobility. So this is the electrophoretic effect. Now we have said that these two effects are negligible in concentrated solution. Why so? Because in concentrated solutions, there are more number of positive and negative ions. There are more number of positive and negative ions and less solvent molecules. So such type of, it is called, sometimes it is called as hydration, hydrated ion. If it is solvent in water, it is called hydrated ion. Such effect is less. But in dilute solutions, these ions are less. They are away from each other. They are away from each other, and because of this, this electrophoretic effect becomes greater. So if there is greater electrophoretic effect, then the mobility will be less. Now, relaxation effect is due to movement of ions. Relaxation effect is due to the movement of ions, ionic atmosphere. Movement of ionic atmosphere. For example, the negative charge, negative atmosphere, ionic atmosphere is moving towards this side, and the positive is moving towards this side. Means the atmosphere, ionic atmosphere, which was randomly distributed, when we apply electric current to that by dipping the electrodes, the electric charges or ions gets divided, gets separated by or towards both two electrodes. In absence of current, these were randomly distributed. But when we apply current to that one, then the negative charge is concentrated or moves towards the positive electrode, and positive charge moves towards the negative electrode. So because of this, the conductance of solution depends on these four factors. Then we have to see the effect of dilution on conductance. So what would be the effect of dilution on observed conductance? What would be the effect of dilution on observed conductance? Either observed conductance decreases or increases. Now suppose we have taken more concentrated solution. Suppose there are 1000 numbers of positive and negative ions in this solution, say 5 ml. Then there is crowding of ions, though it is strong electrolyte. Yes, though it is completely dissociation, and this dissociation is reversible. As in this concentrated ions, these Na plus and Cl minus are close to each other. Then again there is force of attraction, that we see the frictional force, that will be more. Means what? The dissociation of this is less at higher concentration. If we take the another one weak electrolyte, say acetic acid, then its dissociation is less. Dissociation is less. Less number of ions are formed. Less number of ions are formed in concentrated solution. And as the conductance of solution depends upon the number of active ions. Number of active ions. So at higher dilution, number of active ions, number of free ions increases, and because of this, the observed conductance of solution increases with dilution. So the observed conductance increases with dilution because at higher dilution, the electrolyte is completely dissociated. We may say the electrolyte is completely dissociated. The number of active ions increases on dilution, and because of this, the observed conductance increases. Okay. Now, what should be the effect on specific conductance? What is the specific?
Dilution increase झाला तर specific conductance decrease होईल.
Why? It is correct. Specific conductance decreases with dilution. But why? What is the reason? What is specific conductance? Specific conductance is the conductance of 1 cc solution. Is it? Specific conductor is the conductance of 1 cc solution or 1 ml solution. How much electrolyte is added, etc., that does not affect. Okay. Now, if we have dissolved 1000 number of ions or 1000 molecule of NaCl, then there are 1000 Cl and 1000 Na molecules in 10 ml of solution. Then there are 100 ions per ml. If we dissolve same number of ions, say in 20 ml, then there will be 50 ions per ml. And as the conductance depends upon the number of active ions. In concentrated solution, there are more number of ions in 1 ml of solution. In concentrated solutions, there is more number of ions per ml of solution. In dilute solution, there are less number of ions per ml of solution. Because of this, the specific conductance decreases on dilution. Now, what will be the effect on equivalent conductance and molar conductance? What is the effect on equivalent conductance?
Equivalent conductance increase with increasing dilution.
Why? Why it increases? because the dissociation increases. Dissociation increases. Though it is strong electrolyte or weak electrolyte, their dissociation increases. Dissociation increases means number of active ions increases. Number of active ions increases in the solution. Because of this, equivalent conductance increases. Suppose we have taken 1 gram equivalent of electrolyte in 10 ml, then the solubility, all 1 gram equivalent of electrolyte may not dissociate in 10 ml of solution. Okay, though it is strong electrolyte. If we dilute same to 100 ml, then possibility of dissociation of this solution, this electrolyte, is more electrolyte is dissociated on dilution. Suppose same, if we dissolve it in 1000 ml, then complete dissociation will be there. Because of this dissociation, the equivalent conductance increases. Equivalent conductance increases on dilution. Okay. Now, up to what dilution this equivalent conductance increases? Suppose all electrolyte is dissociated completely in the solution, then again we add the solvent, then there is no further dissociation because there are no the electrolyte. There is no electrolyte to dissociate. The number of ions becomes fixed. Number of ions does not increase on further dilution. Then at that condition, what? Still equivalent conductance increases up to some extent. Very small increase is there because the frictional forces there and the relaxation effects were less. And because of this, there is a very small increase, or we may say nearly constant. A situation will be there but when after further dilution, there will be no change in the equivalent conductance. Up to some dilution, there is increase in conductance, and beyond that dilution, there is no any effect on the equivalent conductance because all electrolytes is dissociated. Now that conductance, equivalent conductance at infinite dilution, equivalent conductance at infinite dilution, or conductance, that is called conductance at infinite dilution, that is called lambda infinity. That is called lambda infinity. Lambda infinity is the equivalent conductance at infinite dilution. Okay. Much more dilution is used. Very dilute solution is used, and the conductance is this one. Now, this conductance is equal to the conductance of ions A positive plus B negative. Definitely, this is greater than the equivalent conductance. Conductance at infinite dilution is greater than the equivalent conductance. Now, how to determine the conductors, equivalent conductors at infinite dilution? We are able to determine equivalent conductors. We are able to determine equivalent conductors. We have a formula. kV into P. But how to determine the equivalent conductance at infinite dilution? We know the equivalent conductance is linear with dilution. Equivalent conductance is linear with dilution. Okay, that we know. Now, when we plot a graph, equivalent conductance versus square root of concentration. Equivalent conductance versus square root of concentration. Okay. Then that graph will be like this. See here, concentration increases in this way. Means what? Dilution increases in this way. Dilution is decreasing here. Okay. Now this is the graph. By extrapolating this graph towards y-axis like this, at this there is square root is 0, means concentration is 0. This conductance, this lambda conductance is called, is the taken as lambda infinity. Means the conductance at infinite dilution. So the conductance at infinite dilution can be calculated, can be determined by using such graphical methods. Now, how to measure the conductance? Measurement of conductance. Measurement of conductance. Actually, we are not able to measure the conductance directly. We measure resistance, and by taking reciprocal of that one, we are getting the conductance. For measurement of conductance, what we require? We require some electrode systems and some devices which can measure the resistance. Do you heard about the Wheatstone bridge? You might have seen the Wheatstone bridge. Wheatstone bridge बघितला का तुम्ही? अशा पद्धतीची मोठी असते, 2-3 फुटाची अशी पट्टी असते. This is connected to battery. It is chunky, like this. This is the resistance box, known resistance. This is the electrode system. Solution whose conductance is to be measured is taken here, and this is a jockey. Some galvanometer should be connected here, and this is the Wheatstone bridge. And one more, we require a conductivity cell. So this measurement of conductance we will see later on. Conductance measurement आपण पुढच्या लेक्चरला बघूया. Okay.